Okay, to start off, I started with problem 5-2, which states determine the horizontal and vertical components of reaction at the pin A and reaction of the beam at C. As you can see, I tried my best to draw the picture, but it's always better looking in the book. The first step I took at solving this problem was to draw the free body diagram. As you can see right here, I went ahead and marked out my X, my AY, then from the beam going from D to C, I made that my RCD force. And I noticed there's a triangle between A, D, and C, so I went ahead and marked that angle theta right there. The next step I took was to find the components, and I started off by redrawing that triangle I noted right here. So you have ACD with 1.5 meters on your Y, 1.5 meters on your X. To find that angle, you can use the tangent identity to solve and get theta is equal to 45 degrees. This will then be used later within the problem. After finding that, I went ahead and set up my equilibrium equations. EFX 0, where I notice AX plus RCD cosine theta equals 0. So that's going to be my AX RCD right here. I solved for that. Then I set up for summation at Fy equals 0, where it's going to be my AY RCD sine theta plus the 4 kilonewtons from right here. But that still didn't give me the final answer I really needed. But it gave me what AX and AY could potentially be. So after that, I did a summation at the moment on A, where it's RCD sine theta times 1.5 meters plus 4 kilonewtons times 3 meters. Solving for that, I get RCD is equal to negative 11.38 kilonewtons. With this component, I'm then able to plug back into AX and AY and solve for AX to be negative 8 kilonewtons and AY to be negative 4 kilonewtons. The next problem I started off with doing was problem F-7. The uniform plate has a weight of 500 pounds. Determine the tension in each of the supporting cables. Since it's a uniform plate, I went ahead and marked off this center W, where it's going to be the 500-pound force pushing down. I labeled its components for its vector right here, where it would be 1.5 in X, 2 into Y, and 0 into C. The first step I took at solving this problem was to draw a free body diagram. I really tried my best here. I'm not the best artist. But to show a better picture of what this plate actually looks like, you can look at the real problem here. So the first step after the free body diagram is going to be real similar to the first problem up here. And that is, I want to find my components. I noticed there's no forces acting on X or Y, so I went ahead and solved for the summation of forces on Z, where I put my FA plus FB plus FC minus W, because it's going in a different direction, and minus the 200 pounds that's acting upon right here. Solving for that, you get FA plus FB plus FC equals 700 pounds, which this is a step I got from down here, which I'll explain here in a sec. I did notice there's no moment acting on Z, so I solved for the moments of X and Y. With the moment of X, I was able to get FA times 3 meters plus FB times 0 meters, since they're lying right on the x-axis. FC times 3 meters minus the weight times 1.5 meters and minus 200 pounds times 3 meters. Doing that, you can then take and solve all the way down to where it's FA plus FC equals 450, and this is where this comes back in. We already know that 700 minus FB is equal to FA plus FC, so we do a direct plug in here, where it's 700 minus FB equals 450, which ends up making FB equal to 250 pounds. The next moment we solve for is the y, where it's the same steps as we did up here. Essentially, it's just on the y-axis. So we have FA times 0, since it's right on the y-axis, minus FB times 4 meters, minus 4C times 4 meters, plus the weight times 2 meters, plus 200 pounds times 2 meters. You solve for this, you'll end up seeing that FC is equal to 100 pounds, and we even applied the FB right here. I ran out of space on this page up above, so I went ahead and added it right here. Let's be problem F5-7 continued. Right here, I'm solving for all the forces that needs to be known. We already know that FB is equal to 250 and FC is equal to 100. So to easily solve this force, we then use the equation we did for solving the force of Z, which is FA plus FB plus FC equals 700 pounds. So we apply what we already know into this equation, and we're able to solve FA is equal to 350.